right. So tonight I want to talk about. So last time we talked about independent and dependent events. Obviously, independent events, like really nothing I can do about it. Let's probably have a bad day, given that I don't know. He was probably have a heart attack today, given that the ketchup bottle was empty and put it back in the fridge. It has nothing to do with it. So dependent events, obviously one impacts the other. I was talking to a guy I know today, and his mom, who was 90-something, died last year, but his wife had a stroke the same day. And his mom was his wife was on the phone with his mom's nursing home. And she's like, all of a sudden, that's when she started, because I guess his wife and his mom were really close. And that's when she had her stroke. And they think that probably is what caused it, extra stress. And so that would be a dependent situation, okay? We talked a little bit about this yesterday. Conditional events, probability of B, given that A has already happened. So in other words, A happened, now what's probability B happens? You dropped out of high school, now what's the probability that you end up living on the street? Okay, now that you've already decided to speed, what's probably you get a ticket or whatever, whatever it happens to be. And this is the formula, okay? And so we can do this a couple of different ways. So this is the conditional format. And so you could do something like this. Say, what's probably I get a 2 on a dice and heads. And you're like, geez, Jay, they're independent. I know they are. But what's probably I get a 2 given heads is equal to, all right, well, first of all, probably getting heads is a half. And then to get A and B, that'd be a 6 times a half. And you're like, well, Jay, the halves cancel out. I know. And what does that mean? It means the probability I get a 2 is still 1/6. And what does that mean? It tells me the heads or a coin and a dice are, well, they're independent of one another. Okay? And of course, that's what that always means. Now, the opposite side of conditional, the opposite side of the coin is, well, what if I multiply both sides by P of A, probability of A, times probability of B given that A has already happened? This is equal to the probability of A and B. And that's always true. Now, technically, it's always true. We normally think about this from a dependent probability situation. But it's true for independent as well, because, again, independent probability of B given A is just probability of B. So it doesn't matter, okay? But typically we think about this from a standpoint of dependent events. Again, the other day we did this one a little bit or something akin to it. 6 black, 7 yellow, 3 red, 2 blues, or whatever. And so what's the probability that I get a red and blue? Okay, well, I don't know, and this is without replacement. And so in this case, you're like, all right, well, red, there's 3 reds, 3 out of 13, 16, 18. And then I want a blue, so 2 out of 17. Now it could be red and blue, or it could be blue and red. But either way, there you go. Now you're like, well, what if it was with replacement? Cool. It'd be 3/18 times 2/18. And why is that? Because the probability of blue given red, well, I got red first, didn't we? Probably I get a blue given a red, if I put it back in, is independent. But in other words, probability of B given A is the same as probability of B. So in either case, there it is. Or again, 2/18 times 3/18, because that would be independent. Okay, now that's cute and all. And we could do a zillion other problems like this, okay? Somebody said the other day that certain drinks don't go with certain things. So like, oh my goodness, you heathen, I can't believe you're eating your scalloped potatoes with red wine. Oh my gosh, or, oh dear, the crab Louis with Pinot Noir or whatever, right? I mean, the cretins, okay? And so in that case, okay, obviously that would change, right? So in the case of a I suppose in that case, it'd be like zero chance that a real foodie would drink Pinot Noir with the crab Louis salad or whatever. But in reality, I mean, it could be a situation where, hey, listen, if a person orders a steak, he's more likely to order potatoes or, scallop potato or something. He's less likely perhaps to order, I don't know, French fries or whatever. Versus if he orders a hamburger, he's more likely to do French fries, less likely. Those would be situations of, obviously, dependent probabilities, or you could say conditional either way. Okay? Now, here's a question for you. So, what's the probability that a person buys my insurance, buys a car from me, given the person is, I don't know, 20-something lady. I don't know. But I find that data. Okay? So there was 27, 47, whatever. Let's say 47, 20-something-year-old ladies came in and 2 bought a car for me. All right, cool, whatever. And if you're in real lifetime, you're like, was it conditional? It is conditional, but hang on. What if I want to target certain demographics with my business? Okay. What do you mean? Well, what it means is that let's say I want to target, young females with my car business. Okay. And so, of course, that's how demographics works, right? We figure out what they're into. We sell cars that they like, and then we give them service that, whatever makes them happy. Okay. And of course, then what happens is this. What's the probability that a 20-something-year-old girl, 20-something girl, lady, whatever, buys a car, given that I changed my business model? In other words, I did something, and are we more or less likely now to sell a car to these gals? And boy, I hope so. You get fired, right? Like, there was one, I remember this one problem I put on a test one time, made me so happy. If the probability that a person buys your product is 30%, okay? So in other words, there's like a 30% chance that somebody comes into your store, buys this product or something like that, okay? And then you do an ad, okay? So then probability that a person buys given they saw your ad is still 30%. Well, your ad sucks, okay? It didn't improve your market share. That's the whole point of doing an ad, is to drive up market share and more, probability I sell a product. Okay, cool. Okay, but what if it actually goes like to 10%? Dude, your ad is awful. You freaked everyone out. No one wants to buy your product. They think it's terrible. It is terrible. That's terrible. Obviously, what you'd like it to go is from 30 to 50%. Yay, that's a great product. Now, of course, if it stayed 30, that means your ad, I would say your ad's terrible. Okay, it's terrible. But in reality, that means it's independent. People looked at it and went, but honestly, it's still bad because obviously you need to sell more product. If it went down, it's obviously horrible. If it went up, of course, that's what that's what we want. Obviously, that's the whole point of marketing. Okay, is that people see your marketing campaign, they're like, I cannot live without whatever it is you're selling. Okay, and so that's just things to think about that I want to follow up on. Now, the rest of today, what I want to chat about is what does this look like when it comes to data. Okay. In other words, in a data scenario, what does conditional look like? What does independent look like? And so I want to bring up a few examples here real quick. I'm going to pause for just a sec. Oh, shit. All right. So I'm back. Now what I'm going to do is I'm going to pull up this data set here. And I'm just going to have a look at it real quick here. This Cougars one. The one I showed you the other night. Okay, it popped up the other night. I just want to look at it real quickly. And I want to talk about, what does that look like for me? What is that going to do? Well, apparently I've downloaded it before. Awesome. Oh my word. Okay, again, what does it look like? So here it is. Oh, for the love of Pete. You idiot. Oh, I hate this computer. Oh, you suck. No, stop it. One moment. Looking at new Surface Pros the other day. Apparently they got one with a 13-inch monitor. Good night, nurse. Remember that was a big desktop screen. All right, there we go. Yeehaw! There it is. I highlighted them all. I go insert, pivot table. Boom. Now, suppose I said to you, hey, what's the probability that the dude was from Arizona or Washington? If that's what the question was, well, of course, I don't know. What I'm going to do is I'm going to go state of birth, obviously. State of birth. Oh. I'm sorry, I meant Arizona and Oklahoma. There you go, Arizona or Oklahoma. By the way, you can't be from Arizona and Oklahoma. That's weird. It doesn't work that way. Okay, but here in this case, sure. So Arizona is 3, Oklahoma is 33. So if a person said to you, hey, who's in your hat? Well, there's still 300 folks in my hat. It's out of everybody. Yeah, it's pretty nice. Okay. But when I look at that, I think to myself, oh, okay, well, what does that do for me when I start thinking about probability? Okay. Well, what do you mean? Well, so for instance, that's obviously pretty straightforward in the case of this one because it's just out of everyone. Where it gets interesting is, well, what if I have conditional probability? Well, like, what do you mean? So what's the probability the person was born in Oklahoma given that they like chocolate ice cream? Okay, so I'm going to go ahead and write that. Probability Oklahoma given chocolate ice cream. Okay, now I'm going to do it. Well, who is this out of? This is out of ice cream, chocolate ice cream people. So when I do that, the given part, I personally always put on the filter. That's how I do it. There's other ways around it, but this is my favorite way. So there are 66 people who are chocolate folk, and 5 of those 66 people are born in Oklahoma. Okay? It's that easy. It is that easy. Okay? That's cute. Alright, let's try it anyway. What's the probability that the person hates running given they like strawberry ice cream? No, like given that they live with mom. You're like, Jay, what does that got to do with it? I don't know. It's a good question. It's an excellent question. Does living with your mom affect whether you like running or not? I don't know. It's a good question. Let's find out. So we'll collect some data. Okay? So what's probably the hate running? So I'm going to put hate running or feeling about running here and here. And then which parent they live with. I'm going to put... Well, for God's sakes. I forgot which stupid... It'd be helpful if I'd actually look. So not live with mom. Drives a Chevy. Nice. Drives Chevy. Notice that this is back when I hated running. I actually like running now, but whatever. Ta-da! And who is this out of? It's out of Chevy people. So there's 15 Chevy people, and 2/3 of them hate running. Okay? It's that easy. Oh, disgusting. Anyway, 10/15. 10/15ths. Okay? So good times. It's a lot of fun. It's pretty straightforward to do. Always ask yourself, who is in my hat? Again, that's where we're going with this. Now, why do I care? Well, I care for several reasons, right? So when I look at this stuff, the first thing I think to myself is, well, all right, I find this probability out. Okay, I can use that again as a trend situation. I could use it as a situation of, like what percent of these things are a certain way. Again, percent, probability, percent, probability, proportion, potato, vodka. It's all the same. It's how you want to look at it. Okay? So if I'm looking at days of the week and then what kind of situations I have, so Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Oops, Sunday, don't care. Here we go. And then you got like, this is a network issue, software, hardware, OS, etc., etc., etc. So these are the number of calls on any given day of the week for these different things. Oops. Come on, you hippie. Judas Priest. And then like Tuesday might be 13, and it might be 5, and it might be 7, and it might be 1. And then Wednesday, and then, I don't know, I'm just making this up as I go. 0, 5, 13, 2. And then for whatever reason, Friday looks like this. Apparently everyone's having problems with Windows that day or whatever. Don't know, don't care. Saturday, everybody's playing video games, checking out something on the interwebs, and all of a sudden there's problems galore. All right, cool, whatever. So you look at that, and you're like, oh, okay, cool. Is there a situation where I need to have, is there a situation where I need to like change up again who's more working for me? I don't know. Let's find out. So what a guy can do, of course, is, oops, come on, stop it, escape, try it again, Control C, attaboy, and Control C, like thus, and like thus, and then let's do equals sum just for a good time. And paste that down, so ta-da, and then, actually one more too, just for fun, and then equals sum of these cats. Ta-da! There's 146 total things. And so what a guy can do is you can say, well, are these independent? In other words, do they the same percentages every week? Now, some of you might actually try to do something similar to this. And then there's an actual test for this, okay, to see just how significant a difference it is. But think about this for a minute. If you're doing this here, for instance, this would be equal, for instance, you want to check out your Monday percentages. I take this guy divided by this guy, and leave it in row 6. And what I would do is I just paste this down. So 48% of them are whatever. And so there's still 100% there. And you drag it across. And you're like, Jay, this is so weird. Because it goes from like 16% to 95%. And it goes from 46, 65, 5, 12. What the heck? 0? What's going on? What this says to me, friends, is that this suggests to me that the day of the week, or what kind of problem you have, is different percentage-wise, based on the days of the week. What does that tell you? Well, it tells you that it's dependent on what day of the week it is. You're like, wait, are you saying because it's Tuesday that's causing this? No. Calm down. I never said that. What I said is there's a relationship there. Okay? Again, it comes back to this gal some years ago at PCC. Taught a very intro, basic, it was a cool little course, right? It's called, for the life of Math 105, but I can't remember the name of it was. But anyway, It was just like some cool applied, math for, just the average person. Or maybe we did a little probability in there. It's always fun statistics, just generally speaking. And we looked at some data, and I said, so this just for fun. I said, hey, if I blurt out a car, can you tell me, who's driving the car? So the first one, of course, was a brand new Porsche. Of course, this is in, Portland. And this lady blurts out so loud, "It's an old white man." And I'm like, okay, I think we can all agree he's an old person, for sure, because they're the only person who can afford a brand new Porsche up here in this part of the world. And so, yeah, I would, by and large, that's fair, sure, okay. And so then, what about a PT Cruiser? It's an old divorced lady, probably in her 60s. Okay, probably, all right, whatever. And we went down the line. Okay. And so we did some other ones back and forth. Finally, I said, hey, what about Camry? Well, everybody drives a Camry. Oh, cool. But I said, if you look up here, and I said, we broke it out male and female. I says, do men and women drive the same cars? Well, they clearly don't. I said, well, what we call that is we say what you drive is dependent on gender. And I said, now, again, let me be very clear. That doesn't mean that because you're a gal, you must drive these cars. Because you're a dude, you must drive these cars. It simply says that there is a relationship there that by and large, wait for it, people like different things. Okay. Weird, I know. And so gender maybe influences some of the cars. And she got all butthurt and freaked out. I had to have a conversation with my department head because I triggered her about this. And yet, even at the end of the car, before I had this conversation, before I had to go talk to my department head about her, I said to her, I said, listen, I will bet you $10,000. $10,000. If I told you, I'd bet you $10,000 that I see a pickup with a lumber rack on it, full of lumber, towing a trailer with an excavator on the back. I got $10,000 says that's a woman pulling in to drop off the kids to school in the morning. She's like, oh, you're on. I'll take that bet. I'm like, what do you mean? Well, that's obviously a guy. I'm like, whoa, what are you doing? She goes, well, it's obvious. I'm like, whoa, wait, are you saying that there are certain vehicles that are more likely to be driven by dudes? And she's like, well, obviously. I'm like, oh, that's what I thought. Oh, okay. And again, it's this idea of demographics. That's just how it works. Just how it works. And nobody's upset about it. In fact, we make a lot of money in a lot of ways. A lot of people make money on this situation because they acknowledge it. Okay? If these things were independent, what would you see? It would be the same percentage for network across the board, within reason, obviously. Oh, look, it's 44. Oh, it's 42. Oh, that's different. It's not different. You with me? That's not significantly different. And again, if a guy were to do this test, what you do is you would do a test for a goodness to fit model, all right? And it's a chi-square test and stuff, but it would actually prove this scenario. We're not talking about that right now, but that's one thing that you could do. And again, the idea is pretty straightforward. You look at it and you're just like, well, that's not right. That's not right. That's weird. Okay. And so we take a look at that and just kind of check it out. But again, that is the idea of independence. Okay. So in other words, what's the probability? And each one of these numbers corresponds to a probability. So for instance, right here, this is the probability that it's a network issue given that it's Friday. Right? Given that it's Friday. Given that it's Saturday, what's probably a software issue? It's that right there. Okay? And I could do it the other way around too. I could have totally done it the other way around. It wouldn't make any difference to me. But that's the game. Okay? And then that is where we use these conditional probabilities. Again, if 20-something-year-old boy, or teenage to mid-20-year-old boys, got in wrecks at the same percentages as 45-year-old women. If that were true across the board, right, then guess what? There would be no reason to charge boys more money for their insurance. But that's not how it works, okay? So given that you're a young man, you are more likely to be involved in a traffic wreck or get a ticket or whatever, right? Drive recklessly. That's just what it is. And so that is where that conditional probability comes from. Given that you've already had a heart attack, you're more likely to have other issues. Okay, given that you have diabetes, you're more likely to have other issues. Okay, and as a result, the insurance company is going to ding you harder for that. Okay, I talked to my buddy last night, and he's talking about how he's got type 2 diabetes and this and that and da. I'm thinking to myself, well, yeah, you need to lose some weight. I know I'm one to talk, but wow. And he needs to get some exercise, which he doesn't do any exercise, and this and that. But again, given that you've got this diabetes issue, hey, you're more likely to have, whatever it is down the line, problems. And that's the whole point, right? We all know that's a problem. Ditto, by the way, when it comes to showing some causation with, like, for instance, chewing tobacco and mouth cancer, oral cancer. Okay. So you look at that and you're like, you go out and you sample a couple hundred guys. These couple hundred guys here chew tobacco, these couple hundred don't chew tobacco. Well, look at this. 30% of the people that chew tobacco have mouth cancer. It's 2% over here, including like Michael Douglas, who infamously caught it from, from his wife. That's interesting. But there are other ways of getting it. Okay. Maybe you smoke a pipe all these years. Well, okay, that's fine. I think you probably find someone that's not into tobacco at all, but you show that, geez, there's a huge difference in proportions based on your actions. Ergo, your actions are causing the problem. Okay? In other words, your actions are not independent of what happened. Okay? We got a boss this year. I kicked the kid out of class. She bought him a Slurpee. I went ape crap. Okay? But typically, your actions cause consequences. That's what's supposed to happen. Okay? You touch the stove, it hurts. Yay, you cry. And then, okay, cool. What does that mean? Well, okay, if you ever get burned like that, guess what? You're probably not going to touch the dumb stove again. Okay? And so those sorts of things that, by the way, if you short circuit that, if a kid never is ever allowed, and I'm not saying you should let your kid get run over in the street. See, I told you not to run in the street, you stupid kid. But there's this idea that you don't let a kid have, consequences. All right, out there I don't know, he's out there dorking around, smacking the chickens or something. The chicken pecks him. I told you not to do that, stupid. Whatever. But that's that idea, okay, that your actions, what happens to you is not independent of your actions. Okay, that's what makes things change. Okay. I think one last example of this many, many years ago, and I mean many years ago now, probably been 12, 15 years ago now, had a boss that didn't like me. I didn't like her. We didn't get along at all. And I was supposed to be teaching seniors who were in danger of not graduating and trying to get them to pass their state math requirements, etc. And so she had scheduled them in her infinite wisdom. Yeah, right. For first period. Wait a minute. You're going to tell me you're going to have kids who don't come to school, who are failing school, et cetera, et cetera. You're going to have them come to school first period to do this. Brilliant. So anyway, right, the first day of school is about to start. And I look on my roster, and there's no one on my roster for first period. And I'm like, oh, brother. So as soon as she figures this out, she's going to stick me with like a pre-algebra class. Well, I don't want that. So I look it up and I find out that the Algebra 2 classes are kind of big. So, I could live with an Algebra 2. That sounds okay. So I go find her in the comments and I says, hey, listen, I said, no one's on my roster for first period. And I says, it's kind of stupid that we waste time. Why don't we split the Algebra 2s, we just add another section of that and whatever else. She's like, Jay, I haven't spoken yet. And I went, oh, jeez, here it comes. She's like, we're just going to leave it the way it is for now. And you can work with the kids during your prep period too. And then she walked off. And I'm going to tell you right now, it freaked me out. Because the probability that I had a decent interaction with her, given our history, was about a big fat 0. Okay, it was about a big fat 0. And yet, guess what happened? I had a good reaction from her, which freaked me out because I was not expecting that. I was expecting awful, and I got something that was different. As she walked away, I looked at the vice principal and I go, what just happened? He goes, oh, I told her to leave you alone this year. And I'm like, bro, you got to give me a heads up. You're going to give me a heart attack here. That's ridiculous. And And so we started thinking about that. That's what we're going to be doing as we go through this book, talking about, you're the manager. You do something. What are you trying to do? You're trying to improve customer service. You're trying to improve downtime. You're trying to improve whatever it is. When you're done, what you want to do is this. What's the probability, okay, that this happened given that I made my change? Okay, that's what we're looking at. And you're like, oh, whoa. Yeah, I can show that what I did made a significant difference. That's what conditional probability is all about. Okay? In other words, if you're going along in life and nothing that you do affects you at all, by the way, that'd be creepy. Okay? But what we do as a manager, as a boss, as a person that works with whatever, okay, is we make changes and we want to know that our changes made a difference. Okay, that is, what happened was dependent on what I did. Okay, and if we can show that, and obviously in a positive manner, I mean, obviously we don't, oh, look, I made a difference. Yeah, you made it worse, you idiot. No, we made it better. That's what we want to do, obviously. Okay, and so if we can show that, that's what probability, that's what statistics is all about. But that's what it's all based on, is conditional probability. That's huge. Okay, and so we'll be looking at data later on. We'll be talking about it. We'll be finding the probability that I saw this happen. And hey, that shows that my thing, what I did, affected a change. Okay, it made things better. Okay, that's the whole point. Okay, so I think it's enough of that belaboring that point. Right, so we'll be talking a little bit more about pivot tables next week. So I don't want to shoot it all right now. So pivot table is kind of what we're talking about tonight in that regard. But we get it more from a probability standpoint. Next week we'll get a little bit more into the, define the other pieces and parts of it. Okay? Alrighty, I think that's pretty good.